So today we'll be going to learn cloud computing. Uh, Actually, someone was asking me why we should learn cloud and all. I'm just waiting for them. Okay, let's continue. Maybe at the end we can have a quick session if there is any doubt from anyone. Okay, yeah, this is a definite question as a data engineer perspective. Why we should learn cloud computing? Okay, so maybe is there any correlation between the cloud computing? Maybe you are a cloud architect or just like this, and whether you can also handle data engineers or just this kind of questions. Yeah, definitely it should be. Data engineer is the main perspective, but when you are learning cloud, it's like a infrastructure thing you are learning. But obviously, as a cloud, actually for cloud, if you just go ahead with the courses name, there are lots of certification courses. So if you can just go to courses name, there are lots of courses available. Just for an example, basic cloud computing is there. Just for basic thing, you can know from top of cloud. Cloud developer is there. That means you can spin up the component, and whichever component is required, you can create the pipeline on top of that one and create your own code on top of that. So cloud developers, for the data engineers, they want some Lambda function, step function to be, developed on top of AWS Lambda or step function. So they can develop the same code over there and deploy it in AWS. But if you do not have knowledge on top of cloud computing, then you cannot take the component into account for your development purpose. So that's why nowadays framework driven network is a very popular network. They're always they're not using ETL anymore, or the usage of ETL is getting decreased day by day. So they're using open source languages to create the framework. Okay, and the framework, they can use step function, Lambda function over there as well from AWS, from Azure as well. They have some specific function which are serverless. They're creating those stuffs, the particular code bases on top of that, and they're triggering it. Okay, so this is how the cloud computing should work. So as a basic, as a data engineer, they should also aware of the cloud computing part, especially till developer role. There are also a good certification that is called cloud computing for architects. Okay, so for architects, it's one of the most important thing over there for cloud architect. They need to know each of the component over there, and they need to think about that. Which should be cost efficient as well, because for cloud computing, it's just a portal. Okay, we can go into the portal and we can check various services are available over there. uh, First of all, they will be they will be checked what is your requirement, what is business's requirement. Based on the requirement, they will be checking the component. There are lots of components for same purpose. They need to choose which component to pick up over there, and to create the respective pipeline. And they also need to check how, which purpose they are using, whether we can turn off this particular component when we are idle or when there is no business hour. So that's why we need to check how much cost efficient for each of the component, then use that component. So for architect, it's a bit difficult, but they're also using playing a great role for cloud computing nowadays. Okay, so it's not specifically with the data engineers, but they should also be having data engineers in mind. Some knowledge on top of that one. Okay, I think almost we have everyone to start the session. So till yesterday, what we have covered, Python stuffs we have already covered. I have given an exercise to do. You can just go ahead the exercise. It will take some time, maybe a bit larger than other day. We can solve the exercise maybe 1 or 2 days, after 1 or 2 days. Okay. let's cover up the cloud computing. There are two sessions for cloud computing today and tomorrow. So the basic stuffs we can cover and how it looks like in the portal and all. So that we that will be covering now. So cloud computing, what is cloud computing? If you have the idea, then it's fine. Most of the project they're going ahead with the cloud computing architecture nowadays. I mean, maybe they have the old architecture which are static in nature. They're pointing to a static. Uh, I mean, suppose in Raritan there are data centers. They have chosen some server from there. Okay, so those standalone servers they are no more using. Rather, they are using cloud servers nowadays. Why? And what is the reason for that one? We can covering this thing out in this session. Okay. So what is cloud computing basically? It's the on-demand delivery of compute power. This is the one of the most important stuff, compute power. Okay. So our computer is analyzing the thing or the arithmetic power it is having. We can use that thing when we have demand. So this is the main fundamental concept of cloud computing. When we do not have demand, we will not use that one. We will not pay for that one when we are idle. So this is the cloud computing. It's not only for cloud computing power, it's also for database storage. So we are doing SQL query. When we are creating the tables are being stored. I mean, it's been stored in some particular servers or just like this. So these servers or this kind of storage can be, I mean, also been supported by cloud. If some days just like any particular data center has, I mean, there was some damage, then in cloud there is, I mean, the facility is there. When whatever we are creating for a particular region, the same thing can be copied within another region, so that for disaster recovery, if one data center there is any issue, we can have backup created already in other region, so that AWS, or I mean, not only AWS, actually in this course we will be going through to learn on top of AWS only. There are three bigger cloud providers nowadays. One is Amazon. From Amazon, it's AWS, Amazon Workspaces or Amazon Web Services. Then Google Cloud, GCP, and we are also having Microsoft as a provider. It's Microsoft Azure. Okay, so there are this. I mean, those three things are there nowadays, and those are, I mean, those are very hot skill as well in the market. So whoever has knowledge on cloud, I mean, for a particular, maybe you are working in data engineer, that's fine. You know SQL, that's fine. But you need to apply SQL in some other places. Maybe they require some requirement for Azure Databricks. Okay. So you need to do your technical skills on top of that one. So they are just requiring that whether you have expertise on top of Azure. They need some big data analyst or just like this on top of AWS EMR clusters. So you should be having some experience on top of EMR. Okay. So that is the main thing. Actually, if you have some cloud experience nowadays, then your CV or resume should be having more powerful. Okay. So, and the second point, I just want to mention the same thing. Suppose I have a laptop and I install some software. Okay. I purchased the laptop recently to check. I checked the particular software to be installed for a particular configuration, but the earlier laptop doesn't have that configuration. That's why I bought the new laptop, which should be satisfied that particular configuration and all. So I have installed that particular software. After 1 or 2 years, the new version of the software has been launched, but it is requiring much more capacity or much more configuration. I mean, configuration value from my laptop or my computer. But I mean, my computer has 2 years old only. Should I purchase another laptop? So this is the issue I'm facing now. I just spend money for that one. So this is why we can use or we should use cloud computers. So cloud computers, you can just spin up a particular server for your configuration. Okay, so you can install the software over there, and when you check that the particular software is having a higher version available in the market, so you can decommission your servers as well as the softwares over there, and you can launch another server from cloud, and you can install the same software over there. So this is the thing. I mean, when you require that servers, you can go for the pricing part. You can pay for it. So when it's no longer required, it will not be old. You will not get half price of that. So I mean, when you will be no longer using it, no need to pay on top of that. Okay, just we are renting it. We are not permanently buying that particular component from cloud. Rather, we are renting it. There is a rent cost. Suppose in hour or per second, we have a cost determined on top of each of the component. So while opening the AWS console, or okay, so first of all, we will be learning AWS over here only. Okay. I'll be trying to pick up Azure in next, I mean, for today, I mean, for tomorrow or the next tomorrow. If I have some Azure examples, Microsoft Azure, I can also include Microsoft Azure. But today's session, it's especially focusing on AWS. Okay. So in AWS, whatever component I am having, I have the listing of prices. If I use this component, what price I need to pay. Okay, so I should be having a billing. Maybe this should be a monthly billing, and I need to pay at the month. So, but I can track it. How many, I mean, what usage I have covered and all that I can track it anytime from the AWS console. Okay, so whenever I'll be using that component, I can rent it from there, paying the bills and all. When I do not need that thing, I can decommission it. So I do not need to pay for it. So this is the fundamental concept for cloud. Any doubt from anyone? Any doubt? Nothing? Okay, cool. Okay, so the cloud providers, actually, this is a very good picture, and maybe you have, if you are already, I mean, have some knowledge on top of cloud, you might have seen this picture. Just to elaborate, what is this picture is about? So, on-premises means the particular servers or the particular system that I told earlier. It's not using cloud's infrastructure. Okay, the first thing. The second, third, and fourth, infrastructure as a service, that is IaaS, platform as a service, PaaS, and software as a service. So cloud can provide their support either of these three, any one of these three way. Okay. So first of all, I mean, we have divided the main, I mean, whatever we are doing the services. So inside the services, the main components we have divided in this way: applications, data, runtime, middleware, operating system, OS, virtualization, servers, storage, and networking. Okay, so we have just segregated the services, and by the color code, we can see uh, what thing a particular developer should have to manage and what thing cloud should have to manage. Okay, so over here, this green color, we have to manage. If I am using this cloud components from my side, I have to manage this thing. And the orange color things, cloud have to manage. Okay, so the first one on premises that this is not a cloud provided services. I have to manage everything over here. Okay, but from the second onwards, the infrastructure as a services, we will be renting only infrastructure from cloud. Infrastructure means the servers, the storage spaces, the networking, and the virtualization. So those four stuffs should be supported by cloud, and the rest of the stuffs, application, data, runtime, middleware, and OS, and we means that data developers, or data engineers, we can just have to handle those kind of stuffs. So I just I mean rent I just rented a particular server over there. I launched a server from AWS, but inside the server, what is happening, what software we are installing, cloud will be not bothering at that one. Maybe I have installed something that has been corrupted, so they will not check on top of that one. Okay, because we have chosen IAS over there. We just can take this server. Maybe the server is corrupted and it's not working properly. Then we can reach out to particular cloud vendors. We can have a live chat with them that we are facing this issue. So what is the solution? Then they can help with the servers. How to, tackle with the server, maybe rebooting or any other thing should be helpful for that particular server operation. But they'll be helping on top of that if there is any server related issue. But other stuff, the application data, the software, any middleware part, operating system, whatever I have installed on top, on top of that server, that should be totally our responsible. Okay. So if I just go to platform as a services over there, the red numbers or the orange numbers services has been increased. You can see over there, we are borrowing some, or we are renting some more components, or some more services. Okay, it's runtime, middleware, operating system. So these three got added over here. Okay, so renting from cloud and application and data, it's totally ours. Okay, and the last one, software as a services, you can see cloud is responsible for all the stuffs over here. Okay, so nothing to worry about. So suppose I need a particular software. Okay, maybe I need Tableau, and so I do not. I There is multiple option. I can install. Uh, I can launch a EC2 server there. I can install Tableau and I can maintain Tableau over there. So whenever there is new version, I need to check and update the patch, or just like this. But over here in software as a services, do not think about. We do not have to think about the particular server, where to spin up the server, how to install, if there is any installation issue. So I do not have to think about that. Just I need to just click on Tableau software over there. There is specific thing to be required over. In each cloud component, the cloud, what is the component they will be showing us. Just we need to follow the instruction and spin up the particular software. So when that particular software is ready, we can directly work on top of that. No need to, uh, update the software if there is new patches are available, or just like this. Okay. So everything should be cloud's control. If the software is not working, we just need to have, raise the ticket. They will be checking everything. Okay. Nothing to be bothered about for our work over there. So simple, if you have, I think you learn the concept over here. So if we just go ahead with platform as a services to be taken from cloud, it should be higher price, because they are giving us more support over there. If we are just taking any software as a service over there, it will be the highest one, because infrastructure we can only lend a particular server, but all these kind of things should be supported by them, as well as they are giving the software. Currently just they're telling serverless operation, but it's not exactly serverless operation. There must be server, but the customer should not be thinking about the server. So this is the concept. Okay, and we do not have to pay separately for the server. We just have to pay only for the software. So this is the concept that we are telling it, serverless component. But actually serverless cannot be feasible. If we do not have any computer, we cannot install software. So the concept of serverless, it's not exactly serverless, but the customers, or us, we should not have to think about uh, I mean, which server I need to launch to install the softwares and all. Okay. Hopefully the things are understandable. Moving on to the next slide. Okay. Just some today we'll be just having the introductory session on top of cloud. So what is advantage of the clouds? It is mentioned over here. I already mentioned everything in the introduction part. Just I'm repeating this thing. It's easier IT system management. Very low upfront cost that it should be for, I mean, standalone servers and all. The downtime is very reduced. Suppose we have any maintenance activity over there in a particular region of cloud, then the downtime should be there, but it's very minimal. Okay. Disaster recovery is there. I may already mentioned it. So I need to choose a particular region to launch my systems or launch my component over there. But if some days that particular anything happens, maybe earthquake or anything happens for particular data centers, so cloud is having that capability to take backup from other data centers from other region. So I am choosing a particular region for launching my components and all, but it's not only stored, the backup is not only stored for a particular centers only, it's been distributed in nature. It's also distributing the particular backups into other region so that we can get it when it is required. Accessibility. I can access it from anywhere if I have a good internet connection. So I just have to check with a good internet connection. Scalability, it's also very much important steps. Suppose I have launched a particular server, I am running the servers, it's a runtime thing, and when I'm just running this server, I can check that I need some more configuration, some more hard disks to be added with the server. Okay, I mean, create a request, or I can just check, I mean, check into AWS console. Over there, I can quickly add some more hard disk with some existing server. Okay, give me 1 second. Okay, lightweight devices. Actually, we do not have to think about the devices weight and all because we are not carrying it. This is provided by clouds and all. So, uh, we will be just checking what component do we need to use, their pricing before spinning up any component or before owning any component in cloud. So yeah, those are the definite thing. I mean, definite thing we need to having. So internet connection should be there, a good internet connection. Otherwise, I cannot or we cannot spin up the component. And after spinning up the component, I cannot use a server. Suppose I have spin up a particular Windows server. Okay, so I need to connect this Windows server with my remote desktop connection. So for that thing, I need a good internet connection. Otherwise, there should be lag or there should be issue while doing the operation in remote desktop. Okay, a good security should be there at your system. Otherwise, it should be, I mean, the security should be breached. Suppose I'm doing anything in cloud, but I do not have good security over there. So if this can be hacked as well. Okay, so recurring monthly cost. We need to think about the costing part as well. So, if we just want to have some AWS credential or maybe Azure credential, so we just have to, I mean, before creating the credential, when we are creating some account over there, it will be asking for your credit card or debit card. I mean, it should be international, obviously, international credit card and debit card information. So, suppose, I mean, you have a large bill over there, you are not paying it, it should be just like auto debited or just like this kind of stuff should be there. So just you need to aware of this thing. There should be recurring monthly cost. So each month, whatever you are doing, whatever your billing should be, you need to check it over there and you need to pay for it. Okay. So those are the, I mean, we do not have all the controls. Based on whichever controls you are required for the cloud console, you can use that thing only. So while adopting cloud, we just need to think this point in our mind. So now I am inside a cloud. I'll be just demonstrating the session with particular, suitable screenshots available. Okay. So I am inside AWS console. As we told that we'll be learning AWS as a cloud provider over here in this session. So this is AWS console over here. Also, let me just visit the AWS cloud quickly. How it should be looking like. Just like AWS login. Okay. So if I'm just going with the first time with AWS, so we just need to create an account. Okay. Create an account over here. So we just need to put our details and all, and a particular account should be created. Okay. So when the account is created, we can go to the console. We have the AWS portal again. So we can go inside it and we can check what are the different components over there and all. I do not have a AWS as of now. So we can demonstrate the thing with a suitable screenshot over here in the PPT. Okay. So over here we can check it. The console, if we have the account and all, we can, if we just log in for the first time, the console should looks like this. Okay. Over there you can see at the top right hand side, particular region option is there. So we need to choose which region will be, which should be our base region, that our primary data should be stored over there, or primary components will be building over there. So we need to choose a particular region at the right hand drop down. Even I have also seen that for a particular component to be launched, it should be also varies the cost based on the region as well. Okay, so you need to choose a particular region first of all based on your location as well. Otherwise, when you will be using this thing in remotely, there should be a bit lag. The lag is very minimal, but you need to also think about it. If this is nearer in your location, then the lag would be minimal. If the particular thing, suppose I am in India, I just want to speed up a server. So I need to check what is the nearest location in APAC region. Okay, Asia Pacific. If I just going to build a particular component in just like North Virginia over here, so I can find that some lag should be there. Maybe it should be some seconds or some microsecond. There is no issue, but there should be definitely some lags. Okay, so or you can feel some slowness while using cloud components and all. So that's why we need to choose a particular region which should be nearer to you. Even you can also check the costing of that part. If the costing is much more higher, then you can choose another one, because the particular lagging, I think you will not, there will be no issue for the lagging part for you. Then you can go for the pricing part. Which particular region is having less price component available. So you can choose that thing. Okay. Into the next slide, we can see there is a service button. If we just click on that service, we can see there are lots of services available. Just like over here, compute service, blockchain service, storage service, quantum technologies are available nowadays, analytics service. So those are the different services available or provided by AWS. Okay, and the console should looking like in this manner. Over here, we can have a, okay, I can see this thing over here. So there is this kind of search bar available. So you can directly search for any component. Okay. Suppose for storage spaces, you can search with storage. Or if you already know the component names, just like for storage, we are having S3 bucket. So we can search with S3 over there and enter it. We can check whether in my account there is any ongoing or there is already available S3 is available over there or not. If not, they will always also showing how to launch it and all. They will be showing the component name. You just have to click on this and launch option should be there. Okay, so you can check these stuffs. But the basic console should be looking like this. I'll be just giving with the, particular suitable screenshot with you. I'll be sharing the same thing over here and how the console should works. That thing should be understandable. Okay, just the same thing. Just I search it that root S3 and just enter it and I can find that particular component is available over here. Okay. Okay. Now I just already gone through that. We have already lots of services available in AWS. So each of the services, so just like analytics, if I just search it, what are the analytical services available over here? We can see just like for interactive analytics, we have Amazon Athena. For big data processing, we have EMR clusters. For data warehousing purpose, we have Redshift available. It's Amazon Redshift. Interactive analytics, we are having Amazon Kinesis, and lots of things are available as well. QuickSight is there, Glue is there. Okay, Glue Data Brew. AWS Glue is a different component. It's also available. It's a data brew thing. It's also available. So for analytics, maybe I haven't used lots. All of this thing over here in my practical experience. I have uses. I use Redshift over here. I use EMR. I used Amazon Athena. These three. Not all the thing I have used. But if you have that basic knowledge how uh, that each of the components should be working, especially for the architect role, you need to know some more thing about the components and all, how the components are working, whether you have used already a component. So whether the next component should be working on top of your previous component. So that kind of knowledge you should have to be there along with the prices, what should be price and how should be the usage if you are undertaking this project with this architecture. Okay, so those are all analytical services. For data lake operation, data lake means for data storage purpose, we have this kind of components available. Just like I told you, S3, this is one of the most popular component in Amazon or AWS. Okay, there for backup storage purpose we can use S3 Glacier. This is a bit less price from S3. That's why it's been used for backup and archive purpose, maybe for slowness or just like this. So it's S3 Glacier. And there are lots of things. AWS Glue, I told you sometimes ago. So there's AWS Glue for data catalog part. Okay. So those are all the components available for data storage purpose. For compute services, we are having AWS EC2. EC2 is basically the server as well. AWS Lambda is a serverless compute services. We can get it. There is step function as well. Elastic Beanstalk, Fargate. So those are all being used for compute services. Okay. Database services. We already learned database and we have installed MySQL over there in our system to learn SQLs and all. And over here, we can check that if we just go ahead with a particular software, we can quickly build a MySQL software. We can quickly get a rent on top of that MySQL. We do not think about of the installation part. We do not about think about the patching activity, the version thing. It will be auto updated. Okay, you just have to click one link or just like this, but it should be auto updated. Nothing we need to taking care of. The software is not working. We can raise ticket to solve that issue. But if we are using IAS over there, we need to install the software by our own. If the software is not working, we need to fix it. Okay. But over here, uh, the particular DB, the particular cloud provider should be supporting this thing. We will be just front end user on that software. So we are having for relational database, we are having Aurora database, Postgres, MySQL, Oracle. So those are all different databases. Rather, relational database we can use from AWS. There are DynamoDB. Those are all. DynamoDB is not a relational database. At the first day when we are learning, there is non-relational database as well. So DynamoDB is it's having the storing capacity of as like a non-relational database, no relational database rather we can say. Okay, we can store this thing in a NoSQL format. Okay, similar just like Elastic Cache is NoSQL, Neptune is just like for graphical use or graphical representation of data. I mean, especially for graph theory and all, we can use Neptune. Okay, so those are all database services. I mean, those are all the components available for database services. Okay, yeah, and this is very much important stuff. The cost management thing. There is pricing calculator available. So before taking or before renting any of the component, we need to check the particular calculator, which is pricing calculator. I have just provided this example over here with this portal. So if I just provide with this portal, this is for AWS particular server pricing is there. Elastic Compute Cloud, that is called EC2. Yes. So over here, we can see each of the EC2 instance name over here, their specification, CPUs and memories, how many CPUs should be there, how much memory means RAM size should be there, okay, and how I have to pay for it. Okay, uh, it's hourly cost obviously. Okay, the cost is not much higher. You can see 0.0042. It's USD per hour. Okay, so I think you are aware of that steps. I mean, quite aware. You can check the pricing part before launching any product. There are various specification is available. Okay, which specification you require the thing. So based on that, the pricing should be imposed. Okay, so if you're launching any component, please check the pricing part from the calculator or any other web document, and then launch that particular instance. So this is pricing. I mean, this is the concept of price. I mean, how we can check the pricing for each of the components. Okay, till now, any doubt from anyone? Okay, Firoz, I think, okay, your first name is Sahik, correct?
Yeah, yeah,
Okay, so I think we can discuss on if I think you have some questions earlier yesterday, so we can quickly discuss after the courses is over. And okay, so just let's complete this thing. But if there is any doubt with this existing thing, you can quickly ask the thing over here. So
yeah.
I'm
I
just
just
going to the
joined.
next. Yeah, tell me, please.
Just joined lately, so I will go through the recording. That's
Okay,
why.
fine, fine. Yeah. Moving on to the next slide. Okay, for AWS, there are free tier services, not only for AWS, for Azure, for GCP, every cloud provider, they are providing some free tier services with free cost to have, I mean, to work with some usage of the components and all, to give a demonstration to the customers that they can use which component or just a basic introduction you can have it by checking, or if you are having a free tier services. Okay, just like if we just search with the free tier services, AWS free tier services, for the services we do not have to pay for it. Okay, so you can see uh, if we are having a free tier account, so we can use a particular Amazon EC2. Okay, EC2 is a server. So we can launch the server and we can use for 750 hours per month. So it's free of cost. Okay, but more than that should be chargeable. But all the instances we can also not use. Here are the mentioned instances. We can use either T2 micro or T3 micro, depending on the region as well. So some region maybe it's free tier for T2 micro only. T3 micro is not free tier services for some of the region. So we need to be careful if we are just going to access a free tier services from AWS. So for the particular component, what is the specification? It's 12 months free. Each of the month we cannot use more than 750 hours, and we can only launch either T2 micro or T3 micro. We need to check for that specific region which is suitable for it. Obviously, T2 micro and T3 micro, as this is a free tier account, you cannot expect a 8 GB RAM there. You can also check it. AWS T2 micro specification. I already checked it at the EC2 side. It should not be there. My earlier, yeah, the pricing calculator, I can check the T2 micros instance type and all. Okay, T2 micro. I can get this thing. It's having one CPU and 1 GB RAM. So you can see just for your basic purpose, they are giving you this kind of thing for free tier services. So if you are just thinking that I have a large specification, but this is not possible as this is free tier. So a minimal configuration they will be providing to us. Okay. T2 micro is less, T3 micro is a bit high with one CPU extra over here. The hard disk part, it's not been mentioned over here. We need to purchase hard disk separately. Okay. We need to launch only based on the ROM and the CPU. Hard disk we need to tag with a separate pricing part to this particular compute instance. Okay. Moving on to the next slide. Okay, free tier services. I think you have some idea. Yes. So not only for EC2, there are for storage purpose. We can see for if we are having any S3 bucket, I can use till 5 GB of storage, and I can store till 12 months. Okay. And for databases, we can have RDS and all. You can use MySQL, PostgreSQL, MariaDB, SQL Server for 750 hours per month. Okay. So lots of things are there. A database for Amazon DynamoDB, I told this thing for NoSQL. It's 25 GB storage based on whatever we are storing. Not more than 25 GB. We cannot store for it. AWS Lambda, we can trigger 1 million codes. Okay. And no month limit over here. It's a very good, free tier. We can put big Python code over there if you do not have any environment or if you do not install the IDE, just like PyCharm and all. We can just have a free tier account and we can debug our code over there. Okay. But PyCharm or all that stuff, we are having some, good user-friendly interfaces, or if we are just typing something, it will be helping us with a particular error or particular what it is having a particular, if we are just putting the first character over there, it is gauging what should be the particular method name available on top of that. So this kind of help we can get those ID, which is not possible in AWS Lambda function. So when our code is ready or we have dropped a code, we can put this code and we can run it. If it is fails, then we have to understand it's failed, and the failure log should be always there. There will be no issue. But some disadvantage is there using ID as well as this Python Lambda function in, I mean, using Python in Lambda. Okay. Amazon Redshift is there. So those are all free tiers account. You can just go through these pages and you can check some more things. There are lots of pages available over here for different components. Okay, moving on to the PPT. Okay. So some basic things I just want to mention now. IAM, it's Identity Access Management. Uh, so suppose, I mean, all the access related parts should be maintained by this particular component, Identity Access Management. And suppose you are, I mean, you are the owner of a particular AWS account, okay? And you are owning a particular applications as well. There are support team, there are development teams available, but I mean, they need that component as well. You have the account, so you are the root user of that particular account. Okay. But by this IAM component, you can segregate each of the components access level. Suppose the support team members or maybe the data scientist team member doesn't want all the components access. They only need for particular one or two components access. So you should not have to give your service account and password to them to logging into the console. Rather, you can set up the access management part over here. You can create certain, I mean, for a particular component, you can create certain limits or certain groups over there, and you can add specific user to that groups. Suppose you are launching an EC2 instances. So you can create some groups for this EC2 instances, and whoever needs access to this EC2, you just I mean, give them access only to this EC2 access level. They will not be accessing S3, because as you are the owner of the account, you can launch so many products, 10, 12 products, maybe more than 50 products you have launched it. But you can have the security over there to give specific component access to specific person. Okay. So that is been maintained by IAM, Identity Access Management. Okay. We have the CloudWatch based on how we are using that particular thing and all, as well as the particular networks, the packages in, packages out, those kind of stuffs. All these things we have the CloudWatch, we can check it from there. Just like average CPU utilization, we can check it from here. Okay. Okay. We have the important stuff that is called networking, VPC and networking. So suppose you are launching a particular EC2 server, but to access this EC2 server, that must be tagged with a particular network that should be assigned with a particular IP address. Otherwise, we launched it, but nobody can use it. We launched it somewhere, I mean, maybe North Virginia from here, but we need to access the same thing at any time. So that particular service should be tagged with a networking part. Okay. So VPC is the thing, VPC and networking, they can provide us a lots of a range of IP addresses are available. I mean, IP addresses, but we just need to tag with one IPs for each of the server at a time. So VPC will be helping us with tagging these IPs and all. Okay. So networking is also an important concept over there, and it's readily available in each of the cloud providers. If you are using IaaS, then we can directly check the networking part. So suppose I have launched a particular server, I can see what is its IP address tagged with. Okay. Okay. This is simple actually, when you are quite aware of what is the things going on for each of the I mean, each of the project. So if you are architect of the particular project, then you can create this kind of pipeline. Your data should be coming from the data source system. Then you have to store it in S3 bucket. Then by EMR clusters, it's a big data services using Hadoop. So I mean, the data is processed through EMR, and the processed data is being placed in S3 bucket again. Then on top of S3 bucket, we are creating, we are fetching the data from S3 bucket and putting in the database called a Redshift. And on top of this database, QuickSight, it's analyzing and having virtualization dashboards over there. So on top of Redshift database, someone is creating this kind of dashboards. So if you have the ideas and all, you can create this kind of pipeline. Especially the architect who are in architect role, they are creating the pipeline for the components and all. Okay, so I think you should be having this kind of knowledge after having some more expertise on cloud console. I mean, this is the ultimate goal of this cloud. If you have much more knowledge, what component you need to use, you need to design in this manner. Then you need to launch each of the component from cloud and work on it. Okay, so this is just like an architectural diagram of a particular project using cloud's component only. So those are all the things on the top of, I mean, very much basics as well. So any doubt from anyone till now? No doubt from anyone? Okay. Okay. Now, yeah. So Sahik, you have some questions. So can you please ask me now? We can quickly discuss it over here.
No, like